Hi, welcome you all. In the current video, I'd like to discuss about the few things related to the what is the meaning of unit, what is the importance of unit, what are the types of the units, general types MKS, CGS, FPS, and what are the SI units, then again fundamental SI units, derived SI units, and SI prefixes. This content I want to discuss. So please be with me and listen. NASA tried to put a satellite in orbit so as to understand, so as to know about the atmosphere, weather of the Mars, around the Mars. That mission was get failed. It happened because while performing that project, they had used the unit kilometer as well as miles. In between Earth and Mars, the distance they tried to find out, and sometime they had used kilometer, sometime they had used the miles. So big mission, big project was get failed. And in many different experiments also, errors may occur if the physical quantities, somewhere we are measuring in picometer, somewhere we are measuring in nanometer. Okay, so error may occur. I am not saying always it may occur, but whenever we are doing the practical, so there are the more chances. There should be a uniformity, there should be a easiness. Okay, so for that purpose there should be a identical single unit. Now that I told about the importance, how we can define the unit in day to day practical life, we know mass is measured in kilogram, length is measured in meter, distance, length is measured in meter. Sometime, okay, that SI unit I told, but some other units are also there. So how the unit can be defined? Okay, so unit, it can be defined as arbitrarily decided and universally accepted standards are called as units. That is the definition of the unit or units. Okay, so arbitrarily decided means randomly decided, not in too much planned way. Okay, not in too much in deep scientific way. I should not say non-scientific way, but not too much scientific way. Okay, randomly the things are selected and universally accepted. That should have a universal acceptance. Okay, say for example, or let's try to understand this definition. We know that chemistry is experimental science. Whatever the laws, rules, chemical equations are get taught in chemistry, these are based on the practical facts. Chemistry is the experimental science. While performing the experiments, observations, collection of data, that is carried out. And how the data collection is done? So data collection, either qualitative, quantitative, it involves, there should be a certain specific standard and comparison of the that kind of substance along with the standard. Say for example, I have say this much amount of, say just imagine this much amount of the water I have. Say for example, this is 1 liter, so in comparison to the 1 liter, this is 2 liter, 3 liter, like that comparison we do, and the physical quantities are get measured, either it is mass, volume, length, or anything else. So that's why we need to have a certain specific standard, and that standard is nothing but the unit. Okay, earlier I told you what is the importance of unit, that example of the NASA, and everywhere there should be a unit. Physical property measurement is get carried out. Okay, there should be a certain number, say for example 2, and after that number there should be a unit, say for example 2 liter, 3 meter, or something else. Okay, so if I said only 2, what is the, how much you walk today? 3. Do you have any is there any meaning to this? No. Are 3 meter, 3 kilometer, 3 miles, how much it is? So there should be a certain number, and along with number there should be a certain unit. Okay. Now let's see, earlier there was CGS, okay, MKS, FPS, these systems was there. Okay, in CGS system, length is to be measured in centimeter. In MKS, okay, length is to be measured in meter. In FPS, that length is to be measured in feet or foot, what you may say. Then mass is to be measured in gram. Here mass is to be measured in kilogram. In FPS system, the mass is to be measured in pound. Okay, and in all this system, that time is to be measured in second. Okay, so like that, in different places worldwide, in different time, okay, in different time span, so such a systems, different measurement systems of the physical properties, different units, these are get utilized, okay, developed, utilized. Now there should be a uniformity, and for that purpose, in 1960, General Conference on Weights and Measures, okay, they revised the metric system. Whatever the unit system, metric system was there, that they revised that metric system, and it called as a, they gave name to that as a International Systems of Units, and its abbreviation is SI units. Okay, that is the most important part for us, core part for us, that is the SI units. Now SI units are of the two type, fundamental units and derived units. Okay, so what are the fundamental units? Let me tell you. Fundamental SI units. Okay, so fundamental SI units are for the some 7 fundamental properties. 7 fundamental properties are which one? First one, mass. Okay, physical property I am writing here. Mass, length, time, temperature. Mass, length, time, temperature. Amount of substance, electric current, electric current. Then luminous intensity, so these are the 7 physical properties, fundamental physical properties. Their SI units are mass is get measured in, unit for the mass is kilogram, unit for the length is what? Meter. Then time is to be measured in second, temperature is to be measured in Kelvin. Here it is capital K. Okay, in kilogram K is small, in Kelvin K is capital. Amount of substance is measured in mole, electric current is measured in ampere, and luminescence intensity is measured in candela, CD. Okay, so these are the 7 fundamental units, 7 fundamental physical properties and their corresponding units. Now next to this is derived units. Okay, it's a general part, it is okay na, that we need to know that this is the fundamental unit and physical fundamental property and its unit. Okay, now what are the derived units? Derived units are nothing but the derived units. Okay, derived SI units also we may call. Derived units, example I'll give: area, volume, density, velocity, acceleration, okay, then force, Okay, pressure and concentration, some more are there, that also we'll see. Derived name itself indicate units which are derived from SI units. These are the derived units. Let's see. Area, what we need to know the formula for this physical property, and based on formula we should derive the unit for that physical property. Say for example, area, length is to be squared. Okay, this length and this length I should multiply it. So length square means what? For the length we have the unit meter, and meter square is the unit for the area. Volume, volume is nothing but the meter cube. Say cube is considered. Okay, if the shape is different, volume, different formulas will be there in geometry. Here cube, if we consider meter cube. Okay, length cubed, that means meter cube will be the derived SI unit for the volume. Density, what is the formula of density? Mass upon volume. Mass is measured in kilogram, volume is measured in meter cube. So kg meter raised to minus 3. What is the formula of velocity? That distance traveled per unit time. So distance is nothing but the length. Okay, and that is nothing but the meter. Length is measured in meter and time second per unit time, that's why second raised to minus 1. It can be written as like this also, meter per second. It is also same. Acceleration, its formula is change in velocity per unit time. So velocity is already with us. Okay, formula is with us. So change in velocity per unit time divided by second. So ultimately we will get here meter second raised to minus 2. This is the unit for the acceleration. Force is nothing but the mass into acceleration, mass kilogram, and acceleration, its unit is meter second raised to minus 2. We need to know the formula for the force and all, then we can determine its next part, that is derived unit. Okay, now after this let's see some more derived units. Okay, next one is, that is nothing but the pressure, then concentration. Okay, then what should I take? Electric charge, electrochemical equivalent. Now if you are beginner, you need not to know all these at one instant. While learning the electrochemistry, you will deal with these one. Okay, in chemistry that concentration will be there. Let's see about the pressure. What is the formula for pressure? Force per unit area. And just we have did that for the force unit was, here it was written kilogram meter second raised to minus 2. That is kilogram meter second raised to minus 2. That is for the force. And unit for the area is meter square per unit. So that's why here kg meter raised to minus 1 second raised to minus 2. This is the SI unit for the pressure. Okay. Then concentration. Concentration is nothing but the mole per liter is its unit. Okay, concentration in chemistry very commonly we use amount of substance per unit volume. Amount of substance per unit volume, that is nothing but the concentration. So amount of substance is measured in mole, and per unit volume is nothing but the meter cube, and per unit, that's why it's a mole into meter raised to minus 3. Electric charge is nothing but the electric current into time. So electric current is measured in ampere, time is measured in second. Okay, when 1 ampere current is passed for 1 second, then the quantity of electricity, that is electric charge, is nothing but the 1 coulomb. Are you getting? When a 1 ampere current is passed for 1 second, that is ampere second. It's not as, it's ampere into second. So that is nothing but the 1 coulomb electric charge. And electrochemical equivalent, in electrochemistry this term will come, that electrochemical equivalent is nothing but the amount of substance liberated or deposited when we pass 1 coulomb electricity. Okay, so amount of substance, that substance, amount of substance, mass of substance we should take, that is kilogram. How much kilogram substance will get deposited or liberated when we pass 1 coulomb electricity, that is electrochemical equivalent. So this is about the some derived units. Okay, I hope you will get the idea, you are getting the idea. Okay, and simultaneously might be you are copying. Last point I will tell some important SI prefixes. See, now we are dealing with the some numbers 1 2 10 40 30 like that. Okay, but in chemistry sometimes we are dealing with very big or sometimes very small numbers. Okay, say for example mass of electron is 0.000545 AMU, atomic mass unit, or the Avogadro's number is 6.022 into 10 raised to 23. So very small or very big numbers sometimes we are dealing with. So as to denote them we need such a prefixes. What are these prefixes? Let's see. Here I'll write day, centi, milli, micro, like that we have to write. I'll write here deca, hecto, kilo, myria, mega, giga, tera. Okay, deca, hecto, kilo, myria, mega, giga, tera. Okay, deca means 10, 10 raised to 1, hecto 10 raised to 2, kilo 10 raised to 3. Okay, we say that 1 kilogram, that is 10 raised to 3 gram. Okay, now keep in mind kilo means what, its abbreviation and like that. Okay, we know that capital K, that is the Kelvin unit for temperature, and here kilo small k stands for the kilo. Okay, myria 10 raised to 4, mega 10 raised to 6, and gigabyte, terabyte, these are the words which we know. 10 raised to 9 means giga, 10 raised to 12 means tera. Okay, so these are some SI prefixes: deca, hecto, kilo, myria, mega, giga, tera. Deca I will confirm. Okay, it's a it's a DA, deca. Okay, now some more are there, some more SI prefixes are there, that are nothing but the deci. I'll write here deci, centi, milli, micro, nano, pico, femto. Deci, centi, milli, micro, nano, pico, femto. Abbreviations I wrote. Deci means what? That is 10 raised to minus 1. Deci 10 raised to minus 1, correct. Centi 10 raised to minus 2. Milli 10 raised to minus 3. Okay. And micro 10 raised to minus 6. Nano 10 raised to minus 9. Pico 10 raised to minus 12. Femto 10 raised to minus 15. Some more are there. Atto, femto, and some more are there, but these are enough. Femto too. Okay. So in the current video we discussed about what are the units, what is the importance of units, CGS, FPS, MKS, general things, and afterwards most importantly what are the fundamental units, okay, fundamental physical properties, their units, derived units, different examples, and lastly SI prefixes. Hope that you enjoyed this. Okay, so thank you for watching. Bye.